Welcome to the Tech Talks Daily Podcast, where you can learn and be inspired by real-world examples of how technology is transforming businesses and reshaping industries in a language everyone can understand. Here is your host, Neil C. Hughes.
Welcome back to the Tech Talks Daily Podcast. Now, one of the quickest ways of angering an IT team is when a business user says, hey, my computer is running slow or my application is running slow, because unbeknown to the rest of the business, there's often a civil war of sorts that breaks out between the various teams within IT, as each member of those teams defends the network, defends the server resources, defends the database. And each team will be pointing a finger, a bit like that Spider-Man meme where they're all pointing at each other to say, hey, this isn't me. But bringing all those people together to troubleshoot the issue, that is where the magic happens. And obviously we're now living in a world where many apps are stored in cloud servers, and ensuring that that cloud server can handle the resources of a big application, that is a subject that's being talked about more and more, especially as hybrid working is gathering pace. So I want to explore the ways of identifying problems like this quicker. And a company called SingleStore recently launched a data intensity index, and that is to help companies understand exactly how data intensive their applications are. And using 5 variables, the data intensity index gives them an assessment of the kind of data infrastructure that an application will need to deliver the best user experience. And I believe it's a 3-minute assessment spread over 10 questions, just aims to understand how data is used by the application and then calculate a score. And this really got me thinking, because very often we talk about, hey, moving to the cloud, like it's just a very quick, simple step. But there are so many complexities in that move, especially around choosing the right type of cloud and cloud storage and the kind of resources within that cloud for each application. It isn't a one-size-fits-all. So this is a subject that I wanted to explore today. So with the scene fully set, I'm going to ask you to buckle up and hold on tight, because I'm going to beam your ears all the way to the US, where we're going to speak with Shireesh Thota from SingleStore. And we're going to talk about all this and also explore why data is the most important asset for a company. So a massive warm welcome to the show. Can you tell the listeners a little about how you got here and share your origin story with everyone?
Well, thank you for having me here, Neil. I am a Senior Vice President of Engineering at SingleStore. I have joined a little less than 5 months now, only been here for some time. My background is mostly in databases. I did start my work at Motorola. I worked on embedded systems for a brief while. Then I did my master's in the US, and then I joined as an intern at Microsoft, and ever since been working on databases. I worked on SQL Server as my first job, shipping databases, shrink wrap software. Then was part of the crew that helped move SQL Server into the cloud, made it SQL DB. And for the longest part, I have been associated with Azure Cosmos DB. I'm one of the founding engineers of a non-relational database. This is a document database, a multi-model database, truly speaking, called Cosmos DB, which was born in the cloud. So I went from SQL Server to Cosmos DB, and then recently I also was part of running Citus, which is an open source Postgres scaled out version. So yeah, I've been doing nothing but databases, and now I'm here at SingleStore. I'm very excited to be part of this unique database here.
Well, I'm excited to have you on the podcast today, because SingleStore is the world's fastest unified database for data-intensive applications. But can you just offer an overview of SingleStore and the kind of problems you solve for your customers, and what makes you different from other solutions out there?
Yeah, SingleStore is super unique, as you said. It is a general purpose database with a key differentiation to serve real-time analytics. What it essentially means is that it provides a unified engine for you to bring your transactional workloads and analytical workloads. The most important problem that the businesses have is that they want to minimize time to insights. From the time that a piece of transactional data enters the system to when they want to bring insights into their business, which is effectively building analytics. Now, the typical way to do it, or the traditional way to do it, is to move the data into an operational database, serve your CRUD operational requirements, and then do an ETL operation, move it into an analytical, typically a data warehouse per se, or sometimes build even complex architectures where you sort of have maybe a data lake, lake house and whatnot. The idea there is to basically have specialized databases for every specific aspect of your data flow. SingleStore makes it easy. SingleStore creates all the capabilities in one place. And not just simplifies the architecture, but also really reduces the latency, especially for the time to insights for the business. And it does this in a very unique way. In a nutshell, we serve the operational requirements with an in-memory row store. That's really the origin of the company. That's how we were born. And then we have sort of enhanced that architecture to do columnar disk format and bottomless storage, which is basically moving the data into an object storage, etc. Now, individually, these pieces are not unique, but when the way we put them together makes it really amazing and compelling in terms of achieving your unified needs. That is the sort of quick gist of what we do.
Another thing I'd love for you to expand on, just to set the scene here, is why data is the most important asset for a company, and maybe even the biggest liability if not protected.
No, I completely agree with you. Now, naturally, I think if you sort of think about it from the business goals point of view, before we even get into the technical aspects, the idea of data, there are two things that really it all comes back to decisions. It all comes back to insights. It all comes back to increasing the sort of the business cadence. There are two things there: gathering the data and then making the right insights of the data, right? And of course, there's protection of the data along the way. Now, most of the customers and companies have been doing a pretty good job in terms of gathering the data, right? We haven't had this muscle for quite some time. In fact, even if you go back like a decade ago or something, that muscle wasn't there. Now, I think many companies have evolved to go do that. The way they do it is poor, though, because there's so much of accuracy challenges and cleanliness challenges with data. But at least they do have a way to collect the data. The challenge comes in when they have to protect that sort of governance of the data, and most importantly, insights of the data, right? And both of them are equally important. And that's the reason why the governance aspect is where it becomes a liability. The insights aspect is where it becomes sort of challenging in terms of achieving their business goals. And this is really the reason why most of the business success depends upon how you think about data, how you really gather the insights of the data, and how you govern the data. When you have so much of data, you can easily end up with an architecture that kind of complicates it, delaying the insights. And in fact, you probably won't even get the right insights if you don't have the right data and you don't know how to use the data in the right way. So the architectural cleanliness is very important, aligning to your business goals, of course. And then when you have a large company, or even if it is a small company, when you start gathering so much data, what ends up happening is that the lineage of this data is lost. You may be creating clones of this data because your architecture sort of warrants it. You have different architectures, so you need to make copies of the data. And when you're making copies of the data, you may be giving, it's hard to keep track of the authorization credentials, to who has permissions to what kind of data. It's really hard. So all these pieces sort of make it very hard to govern the data, and then it invariably becomes a liability.
And also, having spoke with so many people on this podcast now, I think we're at something like 2,050 episodes out there. One of the big questions I keep getting around, and one of the big challenges around database sprawl. So just to set the scene, well, not set the scene, to solve this problem once and for all, I appreciate it's a big question, but how can businesses eliminate database sprawl?
Yeah, no, I think the ultimate reason why companies end up with database sprawl is because of this focus on specializations, right? When you think about how to solve a problem, obviously you'll always have multiple solutions, and there need not be one solution for these problems. But there is a runaway effect here. Imagine somebody trying to start out a data platform inside their company. They may start out with an operational database, and then they feel that, the volume of the data is growing. I need to put perhaps a messaging infrastructure sort of like a transport structure, like a Kafka or something like that in front, which is fine. And then you realize that this database is not so great for unstructured data, maybe like schema-less data, like JSON data. Then you probably put a Mongo kind of a database in front. And then you realize that, oh, it's not as fast. You need to really put a caching layer on top. Then you bring in Redis. Well, then you realize that you need analytical capabilities. So you probably transition again all that data, ETL it into a data warehouse like a BigQuery or Snowflake, etc. And you might need to do some more transformations, some computational transformations to do data science and ML, whatnot, and then you move it into Databricks. And these are some examples. Of course, you might have different kinds of choices. And, before you know, you probably are dealing with 20 different systems, 20 different services, let alone reliability, the amount of data that needs to be replicated. Again, just going back to the previous topic about how it becomes a liability, forget about reliability. It's true, and this is a problem that happens all the time. So, to how do we solve this? I do think that we're not suggesting that one size fits all. However, it is really important to not get carried away with extreme specialization. There are amazingly wide variety of solutions that are available, but trying to think about really going back to the fundamental principles whenever you want to add another block, because whenever you are adding a new block, it sort of solves your short-term problems potentially, but you need to think if we can unify these pieces. And you need to have this discipline across the way, right? You cannot just do it once a year or something like that, because going back and changing the architectures is incredibly hard. So I would suggest that it needs discipline to always ask this question every time you're adding a new block, whether you could go and simplify it. It might be more work at the beginning, but it pays dividends in the longer run. So especially when you're thinking about a relational database, a schema-less database, a JSON database, and a cache, for instance, and an analytical database, well, you could actually simplify all these pieces with a database like SingleStore, because there are options where you can build multimodal, in-memory speed, and analytics with transactions all in one place. And this may sound too good to be true, but it is not. And we've proven we have enough collaterals. We've published our white papers. We have TCO benchmarks that kind of go and show TPC benchmarks and go and show how to do that. But it does require that muscle. There's really no silver bullet here, right?
Absolutely. And another thing I wanted to raise is there's so much myths and misconceptions and confusion in a lot of workplaces now, especially with so many different cross-functional working teams there. And we've got non-techies working with techies, and some people can have a little bit of knowledge which can prove to be dangerous, as we know. But so if we look at something like database sharding versus partitioning, can you just lay to rest any confusion there and just explain what the difference is between the two?
Yeah, yes, this happens a lot, and they are converging in many ways. In engineering sort of halls, you would hear them used interchangeably. The difference perhaps is a little esoteric and maybe more academic than in practice. But the core thing here is that partitioning is the logical idea of grouping data in different buckets, because you want to deal with them. For different reasons. You want to have them separately so that you can manage these groups separately, maybe as you allocate resources differently, let's say. Sharding is sort of an example of that. And it's typically designed to say horizontal aspect of sharding, which is really moving the data. When you partition it, you can move the data across different computers, different nodes effectively. So you're scaling out. And that is typically what sharding refers to. And this is just it's a very conventional definition. Again, technically, both really mean that you want to divide the data. Why do you want to divide the data? Well, you want to divide the data because you can allocate the resources efficiently. And most importantly, you can scale better. You can scale in different ways. You could scale up or scale out. Sharding is sort of this movement where scaling out is the best way to go about. So sort of think of sharding, and more specifically horizontal sharding, as a special case of the partitioning. Partitioning is a more general concept. You could do vertical partitioning, horizontal partitioning, etc. And sharding says we need to move the data across different nodes. And when you move the data across nodes, then you could bring in commodity hardware. You can build database architectures that can really provide you the sort of internet scale for the big data problems, right? And again, I would just summarize this by saying that it's more important to think about scale out versus scale up, because partitioning is sort of becoming a very common norm. When you think about scale up and scale out, there are different advantages and disadvantages, and different database architectures do it, different ways. Scale out is, of course, the most popular thing. It comes with a few challenges, but it is the way to go, really, because you could then bring commodity hardwares and you could just linearly scale across. But yeah, most of the modern databases do provide this, especially the cloud the databases that are designed for cloud, right?
Yeah, 100%. And obviously we now expect to work from any device, any location, at any time and on any network. And depending on where those applications are stored on the cloud, people may have different experiences. So can you tell me more about how to build a database for data intrusive applications?
Yeah, data intensivity is something that, we have. It's a concept that really summarizes all the key challenges of the modern data stack problems. The modern data stack is in some sense broken. It's too complicated, in my opinion. Yeah. I mean, the pieces are good. It talks about the sources of data, replications, and then sort of storage, and then transformation, and then visualization. Those pieces are good. There's nothing wrong with it. But the number of options you get in all these pieces is just it's just too many to handle. Data intensity is our way to sort of summarize these challenges, and it kind of creates a nice formula to visualize the problems of the big data effectively. Now, to your question about the applications are growing, of course, yeah. And how do you really think about building a data-intensive application? First and foremost, not every application necessarily needs to be data-intensive. We have built a calculator which kind of goes through and helps you assess if your application is data-intensive. And most importantly, it's a spectrum. It's really not a binary, yes or no. It's like how data-intensive is your application is perhaps a better question. It takes into account 5 different factors. It talks about the size of the data, obviously, big data, more data intensive. The ingestion speed, how fast is your data coming in? It could be, and again, there's different variations here. There's a real-time trickling kind of data versus like suddenly a batch kind of a dump. But nonetheless, the ingestion speed is equally important. And then query complexity. How complex is your query? So you're just doing simple key value lookups, or are you doing some number of joins, for instance? That's just one example. But query complexity is an important factor. Concurrency, how many customers, how many queries are concurrently being thrown at the system, right? If it is really just serving the purpose of like a very handful of customers, you could solve that in many ways, right? So the higher the concurrency, higher the data intensity. And then finally, low latency, right? You definitely need systems that are responsive. Again, time to insights is super important. So even as the complexity of the query is going up, the customers and applications demand lower latency. And that's a really interesting challenge. So when you put all these 5 pieces together, we help you assess these things in a very methodical way. Once you get those pieces done, we can then come up with a way to help you understand how data intensive is your application. Now, this is just to sort of draw attention to the fact that you may need to re-architect, you may need to think about your application in a different way. And now each of these pieces can be solved independently in different ways. The whole, the beauty of SingleStore and really the focus that we are trying to throw light at is the fact that you need to solve all of them holistically, right? For instance, if you just have high volume of data, well, there are many solutions for that. If you just have high complexity of queries, there are many solutions for that. How do you deal with high ingestion, high volume with high concurrency queries and low latency? That is where the challenge is, and there are not too many solutions for those kinds of problems. So if you have an application, it's really important for you to first assess whether you are in that zone or not. And then I think the real answer to your question is to understand how are you trading them off. It's possible that you do have these characteristics, but you put different weights for different parameters, and if you do, then you could probably change your architecture. So that's really the essence of building a data intensive application.
And I think what I love about that more than anything is I think a lot of businesses don't know which one of those applications is the most data intensive. And this data intensity index seems like the perfect solution. How easy is it for a business to run something like this across their application estate? Is it relatively easy for them to get up and running?
It is pretty easy. I mean, we have a very simple calculator. It kind of asks you some really simple pointed questions, really unambiguous sort of questions. It just sort of asks you questions like, do you have 10 terabytes of data, 100 terabytes, etc.? Which is the zone that you fall in? What are the number of queries that you do? How many joins do you have in your queries? So it's very simple, handful set of questions, not too many. And it kind of tells you, really guides you what is the data intensivity. Of course, that's really just the beginning of the problem. And then you need to definitely think through about how to weigh them and how to re-architect to those needs, right? And it kind of really goes back to show that unless you spend some time thinking about these factors, you might end up with extreme specialization and then go into data sprawl and then go into an increased time to insights and so on and so forth, right?
Absolutely. And we've talked a lot about some of the challenges and how to overcome them. What excites you about the future? And also, what role do you see SingleStore playing in this future too? Yeah.
Naturally, this whole industry is full of hype cycles, a lot of jargons. It is true that some of the coolest work that's happening in machine learning, AI, crypto, etc., or it's real. It's really exciting. It's super important. That is going to continue no matter what. I strongly believe in that. Now, what excites me the most, though, is that we as a humanity have an amazing set of problems because that we want to build a sustainable wealth creation for all of the people. And so I do think that we have some incredible challenges ahead of us, be it climate change, be it becoming multiplanetary, etc. I think that's where the entire technical industry is going to be challenged the most. Now, AI, ML, etc., are sort of like crypto, 5G, etc. Those are pieces of it, but when you think about the holistic problem, that's where we'll be challenged the most. And I'm most excited about tackling those problems, right? There are too many tools at our disposal, but these are really gnarly problems. And I'm really the most excited. I think there's so much of space for technologists to go contribute. I would start thinking about those very seriously. Now, you asked a question as to how SingleStore can be part of that. Yeah. Almost all the problems that I mentioned here have an incredible amount of data problem, right? And when you think about how to solve anything, let's just take an example of climate change, right? Believe it or not, it's happening. And when you think about how do you tackle that, you got to bring in an enormous amount of data munching compute capabilities. And the amount of sort of computations that you need closer to the data is significant. It is something that you cannot afford to have really complex architectures for these things. So whether it is a disaggregated compute, whether it is pushing the compute down closer to the data, you need a proper database. You need a proper compute infrastructure for solving these kinds of problems. And of course, I'm not trying to tie one problem to SingleStore here. I'm just trying to give you a pattern here, which is that most of these problems are data oriented at the end of the day. And so simplifying and unifying these pieces is essential for this industry. Because again, otherwise we are just ending up creating way too many complex architectures. And that's really what the modern data stack is. It's broken. It's just too specialized. Those are the kinds of problems that I'm really excited. And I see general purpose unified databases being center of that, SingleStore is really leading that charge.
Well, I've loved chatting with you today. So much helpful information that you've shared there and great insights. Now, before I let you go, I'm going to ask you to leave one other piece of insight and a note of inspiration, that is to leave everyone listening with a book that might have inspired or also a song that helps you get your head in the zone that we can add to our Spotify playlist. What are you going to leave us with today? All I ask is you leave a little story and the reason behind your choice.
Yeah, I would pick a book. Yeah. And the book that really moved me the most in the recent times is this book called Shoe Dog. Shoe Dog is a memoir by the creator of Nike, Phil Knight. And this is sort of a very interesting book. It sort of weaves, he brings his life story and his adventures into building this business all together in the most beautiful way. There's a lot about culture as to how to build a team, a company, and an ethical, sustainable business, and all put together in the most easy to understand and sort of very. I could relate to that really well. One of the things that I would just point out here that touched me the most is that he talks about his experience selling shoes and how he had this sudden success at selling. And he kind of relates it to his past, where he struggled to sell encyclopedias, and Phil is 60s person, so he struggled to sell encyclopedias. He didn't have any success selling mutual funds, but he was incredibly successful in selling shoes. And then he asked this question as to why. It comes down to the realization that he wasn't really selling; he really believed in running. He really, he was an athlete himself, and he was a runner himself, and he truly believed that the world would be a better place if only people use these shoes and sort of help them to better to run in those shoes. So sort of he was really not even selling. He was sort of he was talking about his beliefs, and belief is irresistible. So that's one thing that really moved me, and it kind of comes across all the time in our business.
Love that. I think that's a beautiful moment to end on. I'll add the book to our Amazon wish list so anyone listening can check that out. And before I let you go, though, we've covered a lot of ground in a short amount of time. So anyone wanting to find out more about the Data Intensity Index or what you're doing at SingleStore, what's the best starting point for everything?
Well, so SingleStore.com is really one-stop shop for everything. There is a nice blog which says how to evaluate your data intensity, for instance. But I just wanted to also point out that we have done a launch of our recent announcements. We call it Real-Time Data Revolution. So if you go to SingleStore.com, there is a nice banner that kind of help you to view all those announcements. There are lots of amazing videos and announcement details that kind of walks you through as to what we are doing of late and furthering our mission of building this unified database. So you could go and look at all those pieces at SingleStore.com. We're of course on Twitter, and there's a lot of handles, all with SingleStore effectively.
Awesome. Well, like I said, we've covered so much there, from how to eliminate database sprawl, database sharding versus partitioning, understanding the differences, and also, especially what's really intrigued me is that recent launch of the Data Intensity Index, just to help companies understand how data intensive their applications are. And I know that is a hot topic right now, but more than anything, thank you for sharing that and your very personal story on what put you here. But more than anything, just thanks so much for joining me today.
Thank you, Neil. Thank you so much.
I think when it comes to slow-running applications, we need to be asking more about how you choose the right cloud for each application, and how does your company better troubleshoot issues around this? Would a data intensity index that provides an assessment to help you identify the kind of infrastructure an application will need to deliver that best experience, would that help you? Or do you have something else in place at the moment to determine what application goes on what cloud? Please share your insights and experiences by messaging me now, techblogwriter@outlook.com. Remember, if you want to work with me, my website is techblogwriter.co.uk. Keep those questions and messages coming through. I love to hear how you're dealing with some of the issues that we talk about every day on here. And other than that, I'll return to speak directly into your earballs once again tomorrow. So just a big thank you for listening, and until next time, don't be a stranger.
Thank you for listening to the Tech Talks Daily Podcast with Neil C. Hughes. Remember, technology works best when it brings people together.